In this video, we'll talking about escalators, travelators or movelators and much more. And now let's start. Travelators are used in places with large crowds, especially malls, airports, and a lot of other complexes. And using escalator means you don't have to wait for the lift to arrive or go, right? So you don't have any waiting time at all and can move huge crowds in short time. And can continuously people can get step in step out, so it's a continuous process, right? Now let's see how an escalator works. If we see each step of an escalator, it looks something like this. Okay, so this would be your minimum depth of the step. You don't call it thread or riser in an escalator. Normally, how we used to call it in staircase, thread and riser. So we just call it as step depth or step rise. So here your step depth should be a minimum of 380 meter. No, sorry, not minimum. It should be of 380 mm. Step depth and your rise. Your step rise should be 235 mm. Okay, and you have in each step you have something attached to it called as the step wheel. Now if you imagine another step that is attached to this, you will have another wheel attaching steps together. Okay, so this wheel is attached to the steps and two steps are attached together by another set of wheel. Okay, so if we see this in mechanism here, and this yellow color track that moves along is the track for the step wheel. Okay, so this is your track for step wheel, and this ensures that the steps are horizontal. Okay, so now these wheels that cannot you can't see it because of the track that's running around, but you have wheels here also, right? So these wheels that connect two steps together, they are called the track that runs to them. They are called the track for the step chain. Okay, and they basically pull the steps together. And of course, just like any other electrical or mechanical system, you'll have an electric motor and a drive gear. These two, your drive gear and your electric motor, basically provides power to move the steps and handrails. Talking about handrails, this is your handrail, and the handrail should should be minimum of 900 mm. Okay, and this is your return wheel. Now, if we see how this escalator basically works, your electric motor turns on the drive gear, which rotates, and then the track system goes along it. So each step is basically connected via the track system, right? So they move like this, and then once they reach towards the end, they go in the reverse direction. So they turn over, go down, and then once again they reach the topmost part, they change the direction and then they go. So this is how your escalator moves, and these are the main parts of it. You'll also have an handrail drive as well, to make sure the handrail belt also moves at the same speed as the escalator speed. Okay, this is your, I'll write it here, this is your handrail drive, and these are the important parts of an escalator. It's not as important for you to remember how this mechanism works. Just remember some parts and how, what purpose they do. Okay, and if you see, this is your truss. Your truss is basically like a skeleton or an hollow metal structure which houses all the mechanisms and all the electrical and other parts of an escalator. Basically, it's a skeleton for your escalator. So truss is a skeleton or a hollow metal structure that houses the escalator and its part. So here you can see the drive. You can see the drive gear. You can see the steps folding back and going forth. So these are all the parts. And just like in elevators, how we had a pit for the lowermost landing, right? So this portion is again called your pit, and this is called your comb plate. So comb plates are basically, it has teeth like this, which meshes into your steps basically. Okay, so this is a toothed plate present both at the top as well as the bottom, and these tooth or teeth mesh with your, mesh as an interconnect. Okay, so this is like a groove and interconnecting system, right? So mesh with matching grooves, or you can also call it as cleats on the steps, so that nothing gets trapped in between. Okay, and this plate is called your cover plate, that is present just next to your comb plate is called your cover plate. Your cover plate basically covers all the machinery beneath it. So you'll have, this is your cover plate. This part is your cover plate, and your cover plate covers the machinery below. And apart from the main mechanism and main parts of an escalator, so some other important components are step chain, safety device. So step chain safety device is something that automatically turns off when the step chain breaks, derails, or stretches from its track. And similar to your step chain safety device, you have your drive chain safety device. And as the name suggests, this also turns the escalator automatically off when the drive chain breaks, derails, or stretches from its track. Okay, so very similar to how both the device work. Then you have something called as emergency stop button. Now, these buttons are something that you would have seen. They are present on both the top part and the bottom part, and these are usually the huge red color button. And these buttons allows either the passengers or even the staffs to manually turn off the escalator in terms of not in terms of in times of there is some panic or some cloth is get stuck into the escalators. During those situations, you can manually turn off the escalator. So the red button at top and bottom for manual turn off. Then on all the steps of the escalator, there should be an yellow demarcation so that the the passengers or the people don't step very close to the steps. Okay, so yellow demarcation on the steps, and as this I said earlier, your handrail should move at the speed of the escalator. Sometimes this synchronization between the handrail and your escalator can be lost, okay, and it can be lost due to slippage. So they can be lost due to slippage and wear, and it's called creep. Okay, so these are some of the important components of an escalator. And before I step into different layouts, there is one more thing that I want to talk about: your landing on the escalator, right? So imagine this is your escalator. The landing can be provided of two options. So you should have sufficient space for circulation of the people who are getting down, and that connects with your corridor or an open atrium or whatever space. But there should be a clear distinguish between the landing of your escalator and other circulation space. And this landing can be provided in two options. One is the width of the handrail plus 160 mm. So this can be the width of the handrails plus 160 mm. So it's like 80 mm here and 80 mm here. And this length would be, if it is width of the handrail plus 160 mm, then this can be 2.5 meters. And this is your, let us say, option 1 for landing. Your next type is, this is 2 times the width of the handrail, twice the width of the handrail, plus 160 mm. And if it is twice the width of the handle and 160 mm, then this can be 2 meters. And this is your option 2. And also these all are taken from your NBCs. Refer to them again if you are confused. Okay, so this is your landing space. Now, you would have noticed this in escalators. Your steps don't start automatically like this, right? So whenever you step into an escalator, the steps would be flat for some time, and then it would start going up. And even when you're gonna get off the escalator, it will become flat, and then you'll step down, right? So this flat steps that is provided on the top and the bottom is called your horizontal steps or your flat steps. And these are needed for your safety purposes. Also, make sure the people are comfortable before the step starts going in step directions. Okay, so that this is important. And the number of flat steps also depends upon the speed of the escalator. So your number of flat steps depend upon the speed of the escalators. Now, if we speed the speed of an escalator, the general speed of escalators can vary from 0.5 meter per second or 0.65 meter per second, and the maximum threshold is 0.75 meter per second. So these are the three ranges of speed and the flat step according to the speed, right? So for 0.5 meter per second, you need at least 2 flat steps. These are the minimum I'm talking about. So at least for 0.65 meter per second, you need at least 3 flat steps. And for speeds more than 0.65 meter per second, you need at least 4 flat steps. Okay, now your width, right? So the width of the escalator can range from 0.6 meter to 1 meter. Okay, so these are the different uh, dimensions of an escalator. Now if you see different types of escalator, you have the common one that are mostly seen almost everywhere, which is your linear escalator, which is nothing but goes in your straight way. But there are also different types. This is a spiral escalator. Okay, so basically goes in a spiral way. You also have helical escalator, even free form escalators are also available. Okay, but predominantly we'll talk about linear escalators. Now, if we move on to the different layouts of escalator, there are predominantly three ways. This is your parallel. Okay, so imagine this is A, B, and C. Okay, so you use C to go up to B, and from B you move up to A, and similarly you get down. If you see this in plan, so you'll have, escalators next to each other for easier transfer. So if we see from A, from this A, you go down, to B, from where you transfer to the adjacent escalator, which then takes down to C. Okay, so from A you go down to B, where you transfer to the adjacent escalator, which will take you to the below floor, which is C. Okay, again for going up, you'll start at C, go up, you'll reach B level. From B level you'll transfer to the adjacent escalator, which will take you to the above floor, which is A. So this is parallel escalator, and you will also have multiple parallels if there are two other escalators that are going down and two other escalators are going up. So you have multiple parallel escalator as well. So imagine this is your parallel escalator. So if this is going up, this will go down. Sometime you can have, let's say this is how it is, right? So then in that case, these two can go up, these two can come down, and sometimes in the middle you'll have normal manual staircase. So that is also possible. Then parallel layout of escalator, it has the shortest transition time and path, and therefore has efficient circulation. Okay, so we are done with one type of layout. Now let's move on. This is crisscross. Okay, now again let's consider this. Have A dash, B dash, B, C, C dash. So from A you'll go down to B, transfer to the adjacent escalator, which will take you to C. Again, while going up, you will start from C dash, go up to B dash, take the adjacent escalator, go up to A dash. Okay, if I draw this in plan again, so from A, you are going down to B. So you are going down to B. From B, on the floor level of B, you will transfer to the adjacent escalator, which will take you down to C. Okay, and so on. Again, while going up, you will use the escalator, right? So C dash will take you up to B dash, from where you will transfer to the adjacent escalator, go up to your A dash level. Okay, so here you can see this is a crisscross example. So you'll start at C dash, go to B dash, use the adjacent escalator at B dash, and go to A dash. Again, while coming down, you'll start with A, go down to B, use the escalator, adjacent escalator at B, and come down to C. Okay, so this is how it works. Now the last type, this is called as walk around. So level A, level B, level B dash, level C. So if you see this in plan, it's basically stacking up one floor above one floor, where you have to walk around the path to reach to the escalator that will take you to the next floor. Okay, so if you see this in plan, you are starting at A. So you are starting at A, you'll go up to B, and at level B you have to walk around, reach B dash, from where again you'll go up to C. Okay, again while coming down it's gonna be the same. So you'll start at C, you'll come down to B dash, sorry, yeah, you'll come down to B dash, from where you'll walk around to the escalator at B, go down to A. Okay, so I hope this is clear. Just like your parallel layout, your crisscross layout also uses shortest transition, time, and path. So therefore it has efficient circulation. But this would require large structural opening, and this provides you with the risk of falling into the void. While your walk around escalator, this is usually typical in your stores. So basically has bigger circulation path and takes up your free space. Okay, so these are your three different escalator layout. Now if you see the clear height of an escalator, right? So okay, let's go back to this part itself. Your clear height at all point should be a minimum of 2.3 meters. Okay, so I'll write this here. Clear height above the steps shall be at least 2.3 meters all the time. And in case the escalators are arranged close to each other, usually in your parallel or crisscross arrangement, so if you see, so imagine these are two escalators, then the space between these two handrail should be at least 160 mm. The minimum should be at least 160 mm, it can't go below that. Okay, now let's move on to the formula part. To find your escalator capacity, which is basically the number of people or persons moved per hour. Your n is equal to 360 into p into v into cos theta by L, where n is your escalator capacity, which is nothing but number of persons moved per hour. Your V is number of person per step. V is the escalator speed. L is the length of the step in meters, and theta is the angle of incline. Now, what is the angle of incline, right? So, okay, let's go back to this diagram again. Okay, I'll draw this right here. So imagine this is your escalator. Then this angle should range from 30 degrees to a maximum of 35 degrees. 30 degrees is what generally we use, and 35 degrees are used in case the rise is too small. Okay, this is your rise, and so this theta here is basically the angle of incline. Okay, now we are done with escalator. Let's move to the other variation of it, which is your travelator. Travelators are also called as walkalators or moving walkways. Okay, here also you'll have your comb plate, your handrails, and you'll have this portion which is your skirting, etc. And if we see, travelators are basically flat, right? But sometimes they can be also inclined. In cases of inclination, the maximum angle should be 12 degrees. Your width, this width, it can range from 800 mm to 1200 mm, and your speed can range from 0.5 meter per second to a maximum of 0.75 meter per second. And travelators are usually used in metro stations. No, I don't think it's metro station, but usually used in your airports and all other places. The in one distinguish between your escalator and your travelator is that in escalator you cannot bring your baggage, like your trolley or something, but in travelators you can bring your trolleys and other stuff. And to find the travel time of a travelator or escalator, sorry, travelator or walkalator, so the travel time of travelators is given by the formula T is equal to L by Vt plus Vp, where T is the travel time, L is the length of the travelator. Vt is the travelator speed. Vp is the person's walking speed. As you can know, you can just either stand on it or you can also walk on it, right? So that walking speed is the Vp, person's walking speed. Now let's see one sum based on the travelators. So an airport has a 90-meter long travelator operating at a speed of 0.5 meter per second. A passenger walks at 1.2 meter per second, and they're asking us to find the travel time with travelator, without the travelator, and the percentage time saved. So they're asking us to find three things basically. So travel time with travelator, without travelator, and percentage times saved. Now let's write down the formula first. T is equal to L by V T plus Vt, okay, where L is the length of the travelator, which is 90 meter, and your length should be taken in meters, okay. So length is 90 meters. Vt, which is speed of the travelator, is 0.5 meter per second, and the walking person's speed is 1.2 meter per second. Now let's find the travel time with the travelator. So travel time with travelator is equal to T is equal to 90 by 0.5 plus 1.2, which will give you 90 by 1.7, which is 52.9 seconds. Then your travel time without travelator is T is equal to 90 by, if there is no travelator, there is no speed involved at all, so just put 0. The person's walking speed is 1.2, so you'll get 75 seconds. Now they want us to find the percentage time saved. So percentage time saved is 75 minus 52.9 divided by 75 into 100, you'll get 29.4% time was saved by using the travelator. And we are done with escalators as well.